Hey guys, okay, gonna get right to it. This is where we left off yesterday with the where the Folk radiation belts cut out on us. It was at 11:03, so it would have been Saturday at 21:40 UTC. Okay, we got some more today, and okay, this is where we left off on a video yesterday, 21:40. This is what's transpired since then. Whoa. So we had serious intrusion there at 11:04, 13:40. That's the 2 MeV, 2 million electron volts. So there it is, 13:40. And we only got up, the run only went up to 11:04, 17:40. So you could see all that energy bled in. 13:40. 13:40. And as you can see, it stays in there once it gets in there. Oh, we'll just jump them all up to 13:40. Alright, so there we have that. So I got a ranging from the lowest 10,000 electron volts, 20, 50, 100, 200, 425, a million, 2 million. And we go back to here. It's the latest run on ISWA. They have the 100,000 electron volts up and the 4 million electron volts up, because this is when the gamma radiation starts to occur, when this high energy electron volts begin really stripping away electrons from the atoms that are in there in the vicinity, which creates gamma rays. And the higher the electron volt count, the more gamma rays you're going to get, and the shorter wavelengths they're going to have. So here it is yesterday where we left off at 21:40 on the video yesterday, rather, Saturday at 21:40. You can see, bam, there's that big electron bleed, 13:40. And I think I had that up on the other one, but we'll put it there. So there's 13:40, and it goes up as high as 17. But as you can see, once they get in there, they stay. And this is at 4 MeV. I've never seen these colors in the 4 MeV range. This is insane, in my humble opinion. So I did some more looking, and I pulled up these Folk radiation belts in the L shell time. I think this is the key to understanding exactly how far they're penetrating close to the Earth. Now this is at the lowest range, 10 to 100,000 electron volts. And these L shells are, let me explain to you what those are. L shells, for example, L2 describes a set of the Earth's magnetic field lines which which cross Earth's magnetic equator to Earth's radii from the center of the Earth. So these L shells, this is basically a big magnet, the Earth, and these L shells are magnetic dipole field lines. So that's like a representation there. So if you pull up this, here's the L shells here. Now watch this. I'm just leaving this one play through. Here's on the second. Here's on the third. This is when things started getting really crazy. This is at the highest electron volt count, 1900 to 4000 keV, or 4 million electron volts. There's this is the whole spectrum from 10 all the way up to 4 million. There's 10 to 100,000 and 100,000 to 400,000 electron volts. So as you could see, things were going along pretty good. This is back on the 1st, so that would have been Thursday, 2148. Then watch, this is when we started losing these electron bulk radiation belts. They started lagging them on us. Look how, okay, here it is starting to come in. This is when the event started around 11/2, around 0900. Now watch how it goes. I guess watch this one because it's got a panorama of everything. But here, look, and here. So what I think is these L shells are cracking, man. They are cracking, whatever that means. So these are Earth radii. Each L shell is an Earth radii. So there's 2. There's 1. Guess 1 would be here and 2 there. So this kind of tells you how close this stuff's getting to the Earth. That would be my assessment. That's the best I can do so far with my limited scientific acumen. We'll let it play through one more time and watch out. I mean, things just get crazy. I bet they've never seen it like this before. I bet you. I wish somebody like Astral Traveler or somebody like that could come on and start putting out some videos that actually made complete sense of what's happening. Look at this here. I mean, it went all the way down. It just wiped everything out. And this is the electron flux log. This is that equatorial electron flux. I'm trying to understand what the heck that is, but I haven't been able to decipher that yet. But it has something to do with where these electrons are going. But these are the hours, so this tells you how long these are lasting. So if you think about it as a radiation factor, where radioactive materials have like half-lives, I think this is kind of the same deal, shell time. So this tells you how long these electron counts are staying constant at these L levels, and it's giving them their shell time. And as you can see, once they get in there, they pretty much hang around. So I mean, I don't know, guys. We got a lot of ionized radiation and gamma radiation all around the planet, and are at very high electron volt counts. If you remember, anybody ever watched Astral Traveler, he used to always call it the LEF, low energy field, because you were only getting high electron volt count readings at the low energy levels, like a 10 keV. But ever since I started making these vids back in January, and the electron count volt levels been extremely high. So that just tells me that this nemesis is getting closer and closer, and this is crazy. Too bad we don't have one that goes above 4 MeV. These ones here, I pulled them through. There's no missing time. These are the last 300 frames. But if you notice on this one, remember that big planet's coming our way, past ACE and Discover at the L1 Lagrange point. So here's another diagram on the Lagrange point. So L1's out here. This is 930,000 miles in front of the Earth. This is where the ACE and Discover satellites reside. So that big planet, which was showing up on ACE, it had to have been coming in for quite a while. So ever since January, I was catching like 4 and 5 hour gaps on ACE, data gaps, where it was recording those solar wind speed, density, etc. And then as it got closer, the gaps started getting really big, like 8, 9 hours. And then finally on October 16th, 17th, it passed. And then we had gaps showing up similar fashion, 8, 9 hour gaps for a week or two that were data gaps. They weren't coming from in front of the satellites, they were coming from behind. They were blocking the data feed from the ACE satellites back to Earth, Discover satellite back to Earth. Then after a week or so, that the gaps went away. And there's a couple of moons with it too, that had smaller gaps. So ever since the 16th of October, this big planet passed ACE at 930,000 miles. So it's got to be getting pretty close to Earth. Now here, if you notice these interplanetary magnetic field lines, the blue, they only occur when there's a connection between a planet and another solar body. And look how many we got stacking up in front of the Earth. Now I think some of these are just plain, well, they're magnetic field lines, but they're blue because they're from the other planet and they're stacking up in front of our planet, so that's what's turning them blue. There's like a connection being made. So I think coupled with Nemesis or Herculubus, whatever you want to call it, back here, exerting tremendous electron volt pressure in high numbers behind the planet, and this big planet behind the Earth, and then this big planet coming in from over here, exerting a lot of magnetic pressure, that it's cracking these L shells, and that's why we're getting all this elevated electrovolt pressures. That's the best I can come up with. So I'm running out of time. We'll let this thing play through. These are pretty much synced. I'll just let them play through. Solar wind speed didn't get too crazy either. So I mean, if anyone wants to help me out here, I'd really appreciate it. That has some kind of deeper scientific acumen than mine. I think the next thing we got to figure out is how this electron fluxes work, which are these measurements over here. So let's pull this through. See, when the event started around 11:02, when we got some kind of crazy electron volt stuff bleeding in, high energy stuff, and then look how it cracked it at L3 position. That's it, guys.